Hello, fellow humans. I'm back. I just learned something very fascinating today, so I thought, okay, why not just share it and post a video on it. This is related to the 100 meters men's Olympic finals. So we all know that this is like a sport. It's not. It's an athletic event where even the tiniest of tiniest margins matter the most. So while I was looking at that, I just learned that the speed of sound, how the speed of sound could make a huge impact. Traditionally, the start of this event, especially the finals, it starts with a gunshot. So there will be like someone standing on the sides of those players or the athletes, and they would just shoot a gun, and that will be considered as a trigger where the sprinters or the athletes will start running the 100 meters. Usually the athletes run around like 10 seconds, um, and they cross the 100 meters. And the fascinating thing about that is I think this is the first Olympic finals pretty much all the athletes completed their run in less than 10 seconds. And even more fascinating thing is the difference between number one position and the number two position is 0.0005. Yeah, it's like 1 in 5,000 seconds. And that is so small that the speed of sound could really impact it. Because traditionally, this gunshot is just basically a sound that should travel through the air and reach all the eight participants, because these eight participants that they were competing in the finals, they were lined up, and the guy who's shooting the gun will be standing in one corner, which means the speed of the sound will travel to the first person's uh, zone faster than the person who's standing on the eighth place. So I just made, I don't know if you can see. Okay, you can't see. Oh, you can see. Okay, never mind. So it travels from if there is a gunner here who's just going to start a trigger, and the sound travels to this person much faster than this person. Of course, in like a real world, it really doesn't matter. It doesn't make any big difference, because what, the speed of sound is like 343 meters per second. But we are talking about like Olympic finals, where baddest of baddest margin will make a huge difference. So calculating that, who's standing at what position, we know the person who won was standing at number 6, and the person who came second was standing at number 3. That actually makes a huge difference, because if let's assume that all these runners will run at the same speed. They all have the same amount of acceleration, everything, pretty much their reaction time all are same. But let's say that the speed of sound is 343 seconds, and the gunner will not be like literally standing on the running track. He will be standing outside the running track. Let's say let's give him a couple of meters. So it's 2 meters, and then each track is 1.22 meters of width. So it's like 1.22 meters of meters wide of track. And the guy who came second was standing at the third track, which makes it 3 times 1.22 plus 2 meters. And the guy who's standing on, who came first, he was standing at sixth track, which means it's 6 times 1.22 times 2 meters. So that's the distance between these two athletes and the gunner. The reason why I'm taking these two athletes is because it's the person who came first and then came second, because the guy who came first and the second, they almost ran at the same speed, and they reached the final mark at 9.79 seconds. But of course, it's rounded off to 9.79, but they had a very tiniest difference between these two. So what's happening is the just the the bullet sound to reach the guy in the first track, because there is already a 2 meter distance between the guy in the first track and the referee who is shooting the gun, which means the time it takes to reach the first runner, it will be 0.0058 5 seconds. Now, given that as this time taken to cross 2 meters, now how about the time it takes to reach the third guy or the fourth guy? It will be around 0.014. Now, how about the Lyles, or yeah, Lyles? Yeah, okay, never mind. The person who won the gold medal, he was standing at the position 6, which means that the sound travels and reaches him at 0.02 seconds. 0.02 second is a huge difference, especially when we compare it with 0.02 seconds versus 0.011 seconds. I mean, this is the difference between the person who's standing at number 3 and number 6. And basically, the person who's standing at number 3 came second, and the person who's standing at number 6 came first. Of course, Olympic does not no longer use the gunshots or guns. They have a speaker dedicated for every single player, which means they all get to hear the sound at the same time. There won't be even this tiny difference. But I'm just imagining, if we didn't move into this system of individual speakers, if we would be still using a gunshot, the guy who came second would possibly be winning the gold medal. The guy who came first would probably be earning a silver medal. Like even the tiny fraction, like even the tiny and one more fascinating thing is the guy who came seventh. I mean, that's the same person who was standing at the track number 1. He came seventh, and he ran at the speed of he ran with the timing of 9.88 seconds, which means that it really doesn't matter whether that is a gunner or the speaker. It's not going to impact the results. But what would impact the result is possibly that his speed will be faster. I mean, he would cover the distance in shorter time. Probably he would no longer be at 7th. He could possibly be at like number 4, number 5. For sure, he's not going to be at number 1. But it's really going to make a difference between number 1 and number 2, as that is a delay in hearing every single sound. So why I'm sharing this? There are a lot of things that seems insignificant, especially when you start learning physics in schools. We don't calculate air resistance. We consider a car as a round object, or various things like that. We round it off, but there are some moments where these tiny issues, or these tiny round offs, or these tiny margins are going to matter the most. So it's really fascinating, like of course there are a lot of physicists behind these Olympics, so they already taken these into consideration. But what if they didn't? So just sort of sharing. Thank you.